This is lesson 11.2, and or probability. Our objectives for this lesson are, for two events A and B, find the probability that A or B occurs, and find the probability that A and B occurs. So in other words, what we're doing in this one is probability of A or B, probability of A and B. That's what we're going to learn how to do today. So the probability of A and B happening, that's probability A and B. We use a sample space to count the possibilities and put the number of possibilities over the total. So it's pretty easy. So you just do number of possibilities over the total, right? So you make a sample space and count it up. It's not too bad. Now, the OR probability is harder, okay? So we have a formula for an OR probability. So I would highly recommend writing this formula down at the top of your worksheet or somewhere so that you have it. Okay, so if you have an OR probability, what we have to do is first calculate the probability of A and then add it to the probability of B and then subtract off the probability of A and B. So it's more complicated when we have an OR. All right, so let's try an example. Mrs. Gale has 110 students. The only clubs they belong to are the ballroom dance club and the chess club. There are 75 students involved in at least one of these clubs. There are 43 in ballroom dance club and 24 in chess club. What is the probability that a randomly chosen student in Mrs. Gale's class belongs to both ballroom dance club and chess club? Okay, so this is an and probability. All right. All right, so remember what we need is the total. We want the total of who would belong to both clubs, okay? So we have 43 in ballroom dance club and 24 in chess club, right? So if we add this up, we get 67. Now, there are 75, it says right here, there are 75 students involved in each one, at least one. So there are 75 minus the 67 that are in either one. So this gives us our overlap here. So there are kind of like 8 extra students. So like if you thought of the Venn diagram here, what we just did, there's 43 in ballroom dance and 24 in chess. So we put them together and discovered that there are 8 extra that could possibly be in both. Okay, so that's what we've done here. All right. So 8 possible out of 110. Because 110 students, right? So I want to type this in and then use my little fraction button to simplify it. So 8 out of 110 is 4 out of 55. Okay. Next one, Consuela is playing a card game with a standard 52 card deck. She wants a king or a diamond on her first draw. What is the probability that she will get a king or a diamond on the first draw? So this is the or. This is where we have to use that formula. So we want the probability of a king or the probability of a diamond, and you have to subtract off the probability of, whoops, king and diamond. Hold on a second. King and diamond, okay? So probability of a king. There are 4 kings in the deck, okay? Probability of diamond. There are 13 diamonds in the deck. Remember, a quarter of the deck is diamonds, okay? Now, probability of a king and diamond. There's only 1 king of diamonds in the deck. 1 king of diamonds in the whole entire deck, okay? So that's what we have to do. So luckily these all have a common denominator, so that makes it pretty easy. So 4 plus 13 minus 1, right? And that is 16 out of 52. And if I just reduce this, so 16 out of 52, I can hit the little fraction button to reduce it. And it is 4/13. Okay? All right, so that makes sense. So probability of king, there are 4 kings, there are 13 diamonds, but there's only one that is a king and a diamond. The king of diamonds, there's only 1 card, okay? Next one. Ladarius is playing a board game. To find the number of spaces to move, he rolls a pair of dice. What is the probability that he will roll doubles or a sum of 7? So here's another or one. So we want the probability of doubles or a sum of 7. And we have to do the probability of doubles and sum of 7, right? So here's where having that sample space for your dice comes in handy, right? So you need your sample space. If you have one written out in pen, then you can mark on it with each problem with pencil and then erase it off again so you can use it again. All right. You could even just put one on a little card or something to use throughout the unit. You can use it on the test also, right? All right, so probability of doubles. How many doubles do we have in here? Okay, so I'm going to do probability of doubles in blue. Okay, so you could have 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, or 6, 6. So 6 choices out of 36 is our probability of doubles. All right, what about a probability of a sum of 7? Let's do this in green. So what would add to 7? 1 and 6, 2 and 5, 3 and 4, 4 and 3, 5 and 2, 6 and 1. So there's also 6 of those. Okay, now, probability of doubles and 7. So look on here for how many are both blue and green circled. And look, there's actually no overlap at all, right? So there's a 0 chance of having both doubles and adding to 7. So we're just going to subtract off 0 out of 36 here. Okay, so I'm going to do 6 plus 6 minus 0 is 12 out of 36. And then that will reduce to 1/3. Okay. Next one, 2 dice are rolled. Find the following probabilities. Probability of rolling a sum of 5, and the first die number is smaller than the second die number, okay? So this one is an and probability. So on this one, we're looking for both. So you use your dice sample set. Okay, and we want a sum of 5. And the first number is smaller than the second number. Okay, so we need both things. Remember, the and probabilities are a little bit easier to do. You don't need that formula. Okay, so remember in dice, there's always 36 possible. All right, so I'm going to circle sum of 5 in red. So 1 plus 4 is 5, 2 plus 3 is 5, 3 plus 2 is 5, 4 plus 1 is 5. If you roll a 5, then you're already over. If you roll a 6, then you're already over. Okay, so here's the possibilities of sum of 5. Now, I want first number is smaller than the second number. So here we have 1, 4, the first number is smaller, so that one's good. 2, 3, the first number is smaller. This one's 3, 2, the first number is bigger, so not that one. And 4, 1, the first number is bigger, not that one. So we only have 2 possibilities here that are both, right? And it has to be both. So they're circled in red and they're circled in blue. So there's only 2 out of 36, which will reduce to 1/18. Okay, next one. 2 dice are rolled. Find the following probabilities. Probability of rolling doubles or 2 even numbers. So this time it's a or. So we need probability of doubles. We'll do that one in blue. Probability of 2 even. We'll do that one in red. Okay. Minus probability of doubles and 2 even. Okay. So that one will be things that are circled in both blue and red together. All right, so let me get my little sample space up here. All right, so probability of doubles, we're going to circle those in blue. All right, so just keep going. I should have created a sample space that I should just pop into each one of these. That's okay. All right, so rolling doubles, we're going to do that in blue. So doubles 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. Next, probability of 2 evens in red. All right, so obviously if you roll a 1, you don't have 2 evens. So 2, 2, 2, 4, or 2, 6. And then if you roll a 3, no, so 4, 2, 4, 4, 4, 6, and then 6, 2, 6, 4, 6, 6. Okay, so how many blue circles have I got? I've got 6 blue circles. How many red circles? I've got 1, 2, 3, 4, 5, 6, 7, 8, 9 red circles. And then how many do I have that are circled in both blue and red? So that's 1, 2, 3 of those. Okay, so see how that works? So I have 6 plus 9 minus 3, whoops, and how that adds up to 12. And then we divide that by 36 and reduce it. Okay, so I have 12/36, which reduces to 1/3. All right. Next one, so now we're going to use a Venn diagram. These are also really useful, okay? So we want the Venn diagram shows the favorite sports of 124 students. So if you don't know how a Venn diagram works, right? So you look at one of the circles, so like this circle for soccer, for example. So this means 35 plus 10 plus 6 plus 19, that's the total in the circle, like soccer. But 35 of them like only soccer, right? You have 10 and 6 of them here that like both soccer and baseball, 6 and 19 here that like both soccer and football, right? 6 kids that like all 3 sports, etc. So that's how that works. If you needed to know how many, like this problem gives us the total, 124. If you needed to know the total, you'd have to add every single number in the circle, and that would give you the total, right? All right, so remember in a Venn diagram, OR probabilities are like every single number in the whole thing, and is only the things in the intersections. So if we want football and soccer, let me just grab a highlighter here. So if we want football and soccer, so we're only looking at where the two overlap. So where the two overlap, I should have done like red or something. There we go. So the two overlap there at the right in here, right? This is the overlap at 6 and 19. So 6 plus 19, like football and soccer. Okay? So if I do 6 plus 19, I get 25 out of 124. And when I push my fraction button, this does not reduce, so I just keep it 25 over 124. Okay, so how about football or soccer? So remember, or is everything. So we want everything in the football, everything in the soccer. Okay, now you have to be careful because you don't want to count the things in the middle twice, okay? So it's going to be 35 plus 10 plus 6 plus 19 plus 13 plus 26, all of it. Everything in both, right? Because they could like football or they could like soccer. Just make sure you don't count the overlap things twice, right? Out of 124. Okay, so I'm going to add this up. 35 plus 10 plus 6 plus 19 plus 13 plus 26. I'm just typing it in my calculator. So I get 109. And then we can see if this reduces. Right? It does not. So we'll just leave it like this. Okay? So remember, and it's also called intersection because it's the intersection of the Venn diagram. And U is called union, which is why we use a U for it, union, right? So it's everything in both circles.